Hey everyone, Mr. Skelton here, back at it, Lesson 8, Unit 10. Today we're going to be continuing our discussion on rational expressions, and we're going to focus today on something we call complex fractions. Complex basically means this: a fraction within a fraction. Okay? And whenever we have a fraction within a fraction, we want to make it into one fraction. That's our goal. So let's jump right into it. You can see this problem right here. We have a fraction within a fraction, and I know you're thinking, well, wait a minute, you got a fraction on the top but not on the bottom. Well, you can make this a fraction by putting a 1 underneath it. As we go through this lesson, we're going to get progressively more difficult, so this is pretty basic. Now, the first thing that a lot of students will do and a lot of teachers will teach is to rewrite this problem and think of it in a way that you have seen before, that have been exposed to before. In other words, this. Really what this is saying, right, is 1 over x divided by y. And so what have we done? What did we do in lesson 6, right? When we had fractions where we're dividing, we would take the second one, keep the first one the same, we would change it to its time sign, and we would flip or multiply by the reciprocal of the second. Well, if you do that, you just get 1 over xy, and that would be our answer, right? Because we're always multiplying the top times the top and the bottom times the bottom. Now, we're always going to state restrictions, okay? And so in this case, when we talk about restrictions, I'm going to make a very point here, an important point. With restrictions, don't just look at the answer for possible restrictions. That's a good place to start. But what you really need to do for restrictions is at any point in time within the problem. Okay? And I didn't mention that in lesson 6, I believe, or 7, but I'm making a point of it in 8. Restrictions aren't just, a lot of people will look just here, but you have to look at any point in time in the problem to see if there's any other restrictions. In this case, the restrictions for this problem, x can't be 0, y can't be 0, because if x or y were 0, we'd have a 0 in the denominator, no good. All right? So, let's move on to the next question. Now, we have a situation here where we have 3 divided by this. What you're going to have to do in some of these situations is first, you're going to have to get a common denominator within either the numerator or the denominator. For example, here, 1 minus, I can't do that, right? Because I got to get a common denominator with the 2 y's before I can put this together. I need to push this together with subtraction. In order to do that, I need to get a common denominator of 2y, right? So really this problem gets written like this: 2y over 2y minus 1 over 2y. Now that I have a common denominator on the bottom, I can rewrite the problem as 3 over 2y minus 1 over 2y. So now I have a fraction within a fraction. Now, instead of doing what I did on the first problem, this is what I like to do. I like to just multiply by the reciprocal on the top and the bottom, which is essentially what you're doing anyways. So these reduce out on the bottom, right? And on the top now you basically have 3 over 1. I'm just making 3 a fraction. 3 over 1 times 2y over 2y minus 1. And so what does that give me? That gives me 6y over 1 times 2y minus 1 is just 2y minus 1. That is your answer. No, you cannot go 6 divided by 2 and make that a 3. You cannot do that. People are going to continue to do that. The reason you can is because it's 2y minus 1. It's connected with a subtraction or an addition. So you can't cross out these y's. You can't cross out the 6 over 2 and make it 3 because you have this minus 1 connected to the 2y. Now, in terms of restrictions, what can't y be? Well, you can always set the denominator equal to 0 and see what that would be, which would be 1 basically equaling 2y, so y would equal 1/2. So y cannot be 1/2. is there anything else throughout the point, any point in time in the problem where we would have a restriction other than what we have here of 1/2? And the answer is yes. If you look at this real closely here in terms of restrictions, y can't also be 0 because 2 times 0 would be 0, and 1 divided by 0 would make this problem undefined. So that's what I was talking about back on slide 1, is always be careful of the restrictions. Look at your answer, that's great, but always look back in any point in time in the problem to see if there is a spot where you could have a possible restriction. Number 3, yikes. Okay, so what do we need to do first here? Well, the first thing we need to do is we need to get common denominators in both the top, so the numerator, and then the denominator itself. So we need to, I'm going to focus on the top part. So I'm going to multiply this by x, and this by x, and then this side by y, and this side by y to get my common denominator of yx. It would look like this: 5y over xy minus 2x over xy. Okay? And then divided by, and I'm going to do the same thing down here. This needs to be multiplied by x, this needs to be multiplied by y and by y. So I get negative 4y over xy minus 6x over xy. And then I got to simplify, right? Push those together because it's subtraction now. Because I have a common denominator, I can go 5y minus 2x over xy over negative 4y minus 6x over xy. Okay? Then, now that I have a fraction within a fraction, so all that work just to get to this point in time, now I can multiply by the reciprocal of the denominator. So, because it's multiplication, the whole point of this is to get rid of the fraction within a fraction. That denominator is completely gone. So now our focus is on just simplifying that. Okay? What you'll notice is these, because it's multiplication, these end up crossing out with each other, and you're just left with 5y minus 2x over negative 4y minus 6x. Okay? Now some students will factor out a 2 or a negative 2 in the bottom. You could do that to leave it in factored form, but I would probably just leave my answer just like that. Okay? Restrictions. If you see any restrictions here, especially in the beginning of the problem, you know x can't be 0 and y can't be 0 because of the very beginning. You'd have 2 divided by 0, which would make it undefined. 0 here would make it undefined throughout the process of the problem, and so those are our restrictions for number 3. Last problem here. You can go ahead and try it on your own. Hit pause and try it. See what you come up with. It's a little time consuming, but we'll see how you do. Okay, so this looks fun. We need to, again, first thing, we need to simplify the numerator and simplify the denominator by first getting a common denominator, then subtracting the tops, get a common denominator on the bottom, subtracting the bottoms, and then go ahead and do the division part. So looking at this, I'm going to times this by x, and this by x plus 1, and this by x plus 1, so that I have a common denominator of x times x plus 1. I'm going to do, and you can do this in a variety of ways, or not in a variety of ways, but you can do it in a variety of order. So again, I'm going to multiply this fraction of 3 over x minus 1 by its denominator, and now I got to multiply all this stuff out. So on the top here, I'm going to first, I'm just going to leave it in factored form until I get to the end. I'm just going to leave this as x plus 1 times x minus 2, basically over x times x plus 1 minus 2x over x times x plus 1. So then on the numerator, or on the numerator here, I basically have x plus 1, x minus 2, minus 2x over x times x plus 1. So that's the numerator. On the denominator, I got to do that same work. So I'm going to have 3 times x plus 1, basically minus 1 times that would be just x minus 1. Okay? And that's all going to be over x plus 1 and x minus 1. Okay? So that's my denominator. Now, this gets a little sticky here. Nothing's going to end up crossing out. Well, let's just see what I got here. I'll write this in. Let's see if I get anything out of it. Okay? So there's my denominator, I guess, after simplifying that. So now what I'm going to do is multiply by the reciprocal. Oops, there's a minus sign in there. Minus x minus 1. Okay, so these obviously are all gone because it's the same thing, and then on the top again I'm multiplying, so what can cross out, right? I have the x plus 1s can go. I have another x plus 1 that can go. I have an x minus 1 and an x minus 1 that can go. And let's see, what else do I have? I think that's about it. So what I have left is an x minus 2 minus 2x on the top, divided by, on the bottom, I have basically, let's see, I have an x and I have a 3. This is really a negative 1, so I really have 3 minus 1, which is 2. So I really just have a 2 there. So really what I have is I have x minus 2 minus 2x all over 2x. Now I can still simplify that. I'm running off the paper here. Okay? This is an x, it's really a 1x, so 1x minus 2x should just be a negative x minus 2 over 2x. Answer. Restrictions, obviously x can't be equal to 0. Then we have a lot of restrictions up here, right? X can't be a negative 1, right? Because if I plugged in a negative 1 right there, it would make that denominator 0. X can't be a positive 1 either, because if I plugged a positive 1 in right there, I'm in trouble. And those would be our restrictions for that problem. Now there's a different way in terms of simplifying things that you could have done earlier in this process. Like for example, if you look right up here, when I just rewrote the numerator, I could have crossed out my x plus 1s right away, okay, just on this side, right here and right here, not with this one and this one because it's subtraction, but within that fraction, I could have made my life a lot easier, all right? So I know that's a tough problem there. It's got a lot to it, and I can show it to you again in class if you'd like to see that alternative method of accessing the answer. But again, factoring is important, being able to take your time and really know what you're doing in terms of getting a common denominator, combining the numerators, combining the denominators, and then multiplying by the reciprocal. You got to follow that pattern over and over again, all right? Take care.